Lesson 4.1, power rule in derivatives of polynomials. So we are still talking about derivatives, which means really finding the slope at a specific point of a curved function. And so we had to do this long quotient rule, which was f of x plus h, saying x plus a little bit more, minus just f of x all over h. This is now learning the shortcut way, and I think you'll really like it. First thing I need you to realize is there's different notations or ways of writing the derivative. Sometimes you'll see d over dx, that's just the change in x. You'll see dy over dx with change in y with respect to x. And you'll see f prime of x. All three of these are the same way of saying find the slope at a point. Sometimes they'll also say find the instantaneous rate of change. It's just finding the slope at a specific instance. Okay, so we have power rule. Power rule says that if you're trying to find the derivative, dy over dx, of something to a power, what you do is you take that power in front, so we'll move it, and it'll be n times whatever x was, and then you'll subtract 1 from what the power was. Okay, so I'll show you, like on number 1, if we have f of x equals x to the third power, the derivative of that, I'm going to write d of dx of the function x cubed will equal, move the 3 in front of x, and then we'll take 3 minus 1, which will be x squared. And you'll get super good at this and very quick. And that's it. So this would have been what we would get with that long difference quotient formula. Okay, and then the other thing is maybe you have a number times your x to a power. You'll take still your n in front, multiply it by that number in front, a, and still subtract 1 from the power. So that's like example number 2. If I want to find the derivative of negative 3x to the 5th, I would take the 5 in front, so I'll multiply it with the negative 3. That would become negative 15x. Subtract 1 from the power, be x to the 4th. So it always decreases 1 in power. Okay, the other thing I need to show you is, like, if I have f of x equals negative 4, that's the function y equals negative 4. If I were to graph that, that's down 1, 2, 3, 4. That's a horizontal line. Hopefully remember that y equals are horizontal lines like this. Any slope along here, any little tangent line you would draw would be a horizontal, a flat line, which has a slope of 0. So anytime I have some kind of constant function where it's a horizontal line, the slope at any point on there is just flat out 0. So number 4 might trick you. We see a function e to the third power. E is really like 2.7 something. It's like pi, which we'll see. It's a constant. So taking that to the third power is still a constant. So the slope of that constant function will be 0. Same thing on number 5. Pi is a constant. Pi is about 3.14. 159.6 something something. So if I take that to the 4th power times negative 2, I'm still getting a constant number. So that slope, that derivative would be 0. And then this works on polynomials as well. Can you imagine doing difference quotient with this, where you have to plug in x plus h every time you see an x and having to FOIL that multiple times? That would be awful. So here's how quick this could go. I'll put f prime of x. That's the same notation as finding the derivative. We'll take 5 times negative 4 is negative 20, x to the 4th, plus, bring the 4 in front, 4x to the 3rd, and then negative 9 times 2 would be minus 18x, and then the 7 is a constant. It doesn't have an x. It's like x to the 0. 0 times 7, 0, so that's just gone. So any constant is out. Everything decreases by 1 power. And that would be the answer.